Hello, dear students. I welcome you all on behalf of Sri Jayendra Rank Zone classes. In the previous lecture of wave optics, we have seen and verified the laws of reflection and laws of refraction by Eugene's principle. That means they can also be verified by wave nature of the light. We have also seen the Doppler's effect in light, the redshift and the blue shift. In today's lecture, we are going to understand the superposition of multiple light waves. So, let us begin. We have seen multiple theories of light. There are basically 5 theories of light. One is Newton's corpuscular theory. Second is wave theory. Third is Einstein's quantum theory. Fourth one is the dual nature of light, that is dual theory given by de Broglie. The wave theory will explain the given characteristics and properties of light. That can be explained using wave theory are reflection of light, refraction of light, polarization of light, interference of light, and diffraction of light, among which we are going to see the interference and diffraction of light. First, let us understand the concept of superposition of light or superposition of waves. Let us assume we have a wave. It can be any wave, sound wave or light wave. If a wave of amplitude A1 arrives at point P, now another wave of different amplitude A2 arrives at same point P. The amplitude is A2. Now, if both waves are simultaneously arrive at point P, then the resultant effect we will get is this will be the resultant wave. Having amplitude A is equals to A1 plus A2. Now let us consider the another case. In which again two waves are arriving at point P of amplitude A1 and amplitude A2. These waves again are arriving simultaneously. The resultant wave will look something like this. It will have amplitude A is equal to A1 minus E2. This concept or phenomena of more than two waves simultaneously arriving at a point, and due to them we get a resultant wave, is called the concept of superposition. So when two or more waves arrive at a point simultaneously, then their combined effect is called superposition of waves. Let us see some question based on them. When two waves superimpose in same phase, then what will be the resultant amplitude? Here, the meaning of same phase is this. Both are arriving in same phase of amplitude A1 and A2, then the resultant amplitude will be A1 plus A2. And if they are out of phase by 180 degree, these two are in same phase and these two are out of phase by 180 degree. Meaning of that, the phase difference between these two waves is pi or 180 degree. So resultant amplitude will be A1 minus A2. Here the light waves are in same phase, so amplitude would be A1 plus A2. Next question. When two or more than waves arrive at a point simultaneously to get a new resultant wave, the concept is called superposition. Now, let us understand the mathematical form of superposition of waves. Let us take two waves. One is of amplitude A1 and another of amplitude A2. The phase difference between them is 0 degree. The resultant wave will be a wave having amplitude A is equals to A1 plus A2. Here the amplitude of resultant wave is given actually by the vector addition. So we can write A is equals to under root A1 square plus A2 square plus 2A1 A2 cos theta. Here theta is the phase difference between the waves. Phase difference between the waves. In this situation, theta is 0 degree. So A will be under root A1 square plus A2 square plus 2a1 a2 cos 0 is 1. So a will be equal to a1 plus a2. This is how we have got the relation. If they are out of phase, then if waves are out of phase by 180 degree, then put theta is equals to 180 degree in this equation, and we will get a is equals to under root a1 square plus a2 square plus 2a1 a2 cos 180 degree. But cos 180 degree is minus 1. So a will be under root a1 square plus a2 square minus 2a1 a2. This will give us the answer a1 minus a2. Now, let us understand the principle of superposition of waves. What is the principle? When two or more than two waves arrive at a point simultaneously, then the amplitude of resultant wave is given by the vector sum of the amplitudes of each waves. When two or more than two waves arrive at a point simultaneously, then the amplitude of resultant wave is given by the vector sum of the amplitudes of each wave. That is, a is equals to under root a1 square plus a2 square plus 2a1 a2 cos theta. Let us see some questions based on this. According to the principle of superposition, the amplitude of resultant wave is given by the vector addition. There are two waves of amplitude 4 units and 5 units respectively, which arrive at a point simultaneously such that phase difference between them is 60 degree. What is the amplitude of resultant wave? Here, the phase difference between two waves is 60 degree. So theta is 60 degree. A1 is 4 unit. And A2 is 5 unit. So let us use the formula. A is equals to under root A1 square plus A2 square plus 2 A1 A2 cos theta. Put all the values. 4 square 16 plus 5 square 25 plus 2 into 4 into 5 into cos 60 degree. Cos 60 is 1 by 2. So we will get the answer root 61 units. Now, let us understand different sources of light that are coherent and non-coherent sources of lights. First, what is non-coherent source of light? Two light sources are non-coherent we can say they are non-coherent if the frequencies are not same and phase difference between the waves emitted by does not remain constant with respect to time. So, the two sources of light whose frequencies are not same and phase difference between the waves emitted by them changes with time are called non-coherent sources. There are two conditions. The frequencies of the two sources are not same and the phase difference changes with time. Here, the light emitted by any two independent sources of light are non-coherent. And if light sources are non-coherent, then the interference phenomenon cannot be produced. Interference phenomenon can be produced only when the light waves differ in phase only, and the phase difference must be constant, plus their frequencies must be same. Here, if the sources are non-coherent, their frequencies are not same, and the phase difference is also not constant, so the interference cannot be created. The example of such sources are candles, bulbs, etc. These are the independent sources of light, and due to their combined effect, interference cannot be created. Now let us see coherent sources. If two sources of light whose frequencies are same and phase difference between the waves remains constant with respect to time, then they are the coherent sources. Two sources whose frequencies are same and the phase difference between the light waves emitted by them is constant. It is independent of time. Then these two sources are coherent sources. Frequencies are same and phase difference between light waves is constant. It is independent of time. Then they are coherent sources. They can be obtained by same source or single source of light. The laser light is highly coherent and monochromatic. So it is the example. the laser light is coherent source. The distance traveled between them is very small. These sources are of two types: spatial coherent sources and temporal coherent sources. Spatial coherent and temporal coherent sources. There are two methods of obtaining these sources. One is division of wavefront and one is division of amplitude. The methods of obtaining coherent sources. One, by division of wavefront, and second, by division of amplitude. Let us see the methods one by one. First, division of wavefront. In this case, the light source taken is narrow. The wavefront emitted by narrow source is divided into two parts by reflection or refraction. So the wavefront is divided in two parts, either by reflection or by refraction. The coherent sources obtained are imaginary. They are imaginary. It is important to note. Second method is division of amplitude. In this case, the light source is extended source, such as tube light. The amplitude of wave emitted by an extended source of light is divided into two parts by partial reflection and by partial refraction. One is by partial reflection and another is by partial refraction. In this situation, the coherent sources obtained are real. The laser light is highly coherent, non-coherent, monochromatic. The correct option is D. It is highly coherent and monochromatic source. The Fresnel biprism is an example of, it is the example of division of wavefront. This is all for today. Thank you.